You guys can hear me okay? Before we get into today's lecture topic, I just want to check and see how you guys are doing regarding course content and the homework and any of that stuff. Any feedback? I got a thumbs up, so that's good. Okay. Yeah. So this first week's homework was intended to be gentle and easy, and I'm hoping it's not causing you guys too much trouble. Some of you might not have had any experience with R, and if that's the case, you technically should not have enrolled in this class, but I'm hoping with this first week being gentle, you can go through the resources that I've posted on CCLE and at least gain some familiarity with R. And I'm hoping at least these lectures are giving you an idea of some of kind of the internal structures in R, and then next week we'll focus on some flow controls with if and else statements, things like that, writing functions and programs. Okay. All right. So today we'll talk about subsetting, and there's actually a lot of functions in R. Well, maybe not a lot, but there's several functions in R built for subsetting. Namely, there's the subset function, and then if you use package dplyr, which I'm a very big fan of, there's the function filter, and these effectively perform a lot of subsetting operations. However, I think there is great value in learning the basic subsetting features within R. Okay. And so, subsetting might be a little bit difficult in the beginning with R, and that's because you've got several things going on together, and they can be combined. But when you do it, it's quite powerful. So we'll start off with talking about subsetting with just the single bracket. And so technically the function is just the single left bracket, okay? But I think we're accustomed to seeing both the left and right side. So I'm putting in both the left and right side, although technically the function is just a single left bracket. Okay, and then that generalizes to the double left, or the double bracket, or double square bracket, and the dollar sign. And then you can use subsetting for assignment, and we'll also encounter some important applications of subsetting. And I have to give credit to Hadley Wickham for really summarizing all of these important functions of subsetting into a kind of a nice thing here. Okay, so we're going to just start off with with a simple atomic vector. Okay. And it's just these four numbers, so this would be type double, and this is written in such a way that the number after the decimal tells you the position in the original vector. Okay, so 4, 2 is in the second position. Okay, and you can subset a vector using I wrote 5 things, but positive integers, negative integers, logical vectors, and character vectors, and then there's a few special cases which would count as the 5 things, but these are probably your primary ways of subsetting a vector. Okay, so with a positive integer, inside the square bracket returns elements at the specified position. Okay, so you tell x, I want the number in the third position and the number in the first position, and it returns that to you. Okay. If you say, I want the order of x, okay, that gives you a sequence of integers that you would use to put them in order from least to greatest. So if we just flip back, the smallest one is the first one, the second smallest is the third, the next smallest is the second, and then the last one is the fourth, and that's what this shows. Okay, it says if you want to put these in order, this is the positions that you would choose. So it's different from a rank or different from a sort, okay? And then so you say, you subset X using order, piping, basically putting this thing inside here, and you see them arranged from least to greatest. Duplicated indices, so if you put in 1 and 1, it will yield duplicated values, okay, so no problem there. And then if you throw in real numbers, so, you know, this is actually type what? Type double, right? The default numeric mode, these are not technically integers, but they get coerced to integers essentially when you put them inside the bracket. Okay, and so these turn into just integer 2, and so it returns the second item in the list. Okay, negative integers will omit elements at the specified position, so this is effectively -3 and -1. So we're getting our list back without the third or the first elements. Okay, but you can't mix positive and negative integers in a single subset because it doesn't know what to do, right? Effectively, if you give it just -1, it says, give me everything except the first one. And then this one says, give me just the second element. So then it says, well, you're giving me conflicting instructions. I don't know what to do. Okay. You can also subset using logical vectors. And it will return you the values that correspond to true. Okay, so we have 4 elements in our vector x, and if I say, okay, true, true, false, false, it will give me back the ones that correspond to the first 2 positions, but not the later ones, false, false. Okay. Here, the x greater than 3 is going to produce a logical vector, right? It's going to do a test. Is x larger than 3? And that will turn into trues and falses. And then, so it will be true whenever x is bigger than 3, and it will be false whenever x is less than 3. And so when you put that inside the bracket, effectively you are subsetting x to just values of x that are greater than 3, because it's returning the values where that correspond to this statement being true. Okay, and so this is very useful if you're just trying to filter out elements in a vector, and or later on in DataFrame you can do these kind of logical statements. Okay, if the logical vector is shorter than the vector being supplied, we learned about element recycling, right? So seeing if I pipe this, or not pipe, if I put true, false inside the bracket, okay, effectively what we're telling it is true, false, recycle, true, false. Okay, because there's 4 elements in x, so it's going to say, okay, true, false, and then I've run out, so I'm going to do true, false, so you get the first and the third elements. So far, so good? Okay. And a missing value in the index always yields a missing value in the output. So you can say true, true, and then NA, false. So it will give you back the first, the second, and then an NA. And then it won't give you the fourth because you said false. Yes?
In the previous slide where you had the second statement, x is greater than 3, you said that it converts all the numbers to true and false statements. So do you have to preface that? Like, do you have to do the previous statement in order for it to output the values that are greater than 3, or does it do that automatically?
Okay. So this is a logical statement, right? so that it doesn't turn the numbers, but you've got 4 elements in your list. You're effectively recycling the 3 across all 4 elements, and then it's going to compare each element against 3, and it's going to give you a true, false. Wait, I'm sorry. And your question was?
So you don't have to do the previous one, it just does it automatically, right? Like the x is greater than 3, it already does a logical statement?
Yeah. So this, when it evaluates this, it's going to evaluate the inside, this part first, and internally, it's going to store it as true and falses in memory, and then use that to then pick out the elements in X. You don't need a separate statement that says X greater than 3, and now I'm going to take that result and put it in here. Okay. So it's very convenient. Oops. Okay, and then this is what happens with missing values, right? So why would you want this? Well, sometimes as you're doing dealing with data, okay, maybe in your data there's a missing value, and that's going to propagate if you're trying to use a missing value to then pull something else out. Okay, so special cases, if you put in nothing, right, X bracket and nothing inside, it'll just return back the entire vector. Okay, and then if you put in 0, element 0, effectively it's giving you going to give you null. Okay, but there's different classes of null. Okay, just like there's different, or not, I shouldn't say classes. There's different types of null. There's like an integer null and a character null and things like that. And so when you with X being a numeric vector or a double, it's going to give you the null that corresponds to numeric type. And or so if you have a character vector and you put in x0, if X is a character vector, it'll give you character 0, null of character type. I don't know how often you're going to be testing for these things, but it's good to be aware of it. Okay, so let's say we set the names of of X, we give them names, and we just say A, B, C, D. Okay, so we're using the function set names. That's effectively equal to names of X is now equal to letters 1 through 4, but set names creates a duplicate of X, right? A copy of X, and we store it into Y. So we have this. Okay, now we can subset using names. So I can say, give me Y where the names are D, C, and A. Boom. Okay, and just like other things, you can use repeat your indices, and you'll get that. And when you subset with the square bracket, names are matched exactly. So if the names in Z are A, B, C, and D, E, F, and you ask, give me A and give me D, it's going to say, I can't find that. These are missing in your vector. Subsetting a list works in the same way as subsetting an atomic vector. Using the single bracket always returns a list, whereas the double bracket or the $sign will return a component in the list. Okay, and I'll distinguish that a little bit more later. So let's say we create a list with A, B, and C. A is this numeric vector 1, 2, 3. B is a logical vector, true, true, false, and C is a character vector. Okay, and so if we look at the structure of D, it says, oh, you've got three things in there. Okay, and so if I do D bracket 1, it gives me back a list of A, the object A in the list, and it says the stuff inside that list is this numeric vector 1, 2, 3. Okay, so using a single bracket will return a list. So even though A itself is a numeric vector, when you use a single bracket to subset D, what you get back is a list. So that might throw off certain behaviors if you're feeding these into a function that's expecting a vector. So make sure you're using the correct thing that you want to do, okay? And we'll talk about just this distinction between single and double in a moment here. Okay. You can also subset higher dimensional structures, such as matrices and arrays, okay? and you can use it using multiple vectors, okay? Like if you have a matrix that's got 2 dimensions, right? You can use two vectors to subset a matrix. You can use a single vector to subset a matrix, and you can also subset using a matrix, okay? So probably, with multiple vectors is going to be probably the most common way, where you separate these vectors using a comma, so that the first vector corresponds to the row that you want to subset, and the second vector corresponds to the columns that you want to subset, okay? So I didn't print out A, but you can imagine A being 1 through 9, right? And it fills out column-wise, so it's going to, you got 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to give these columns the names A, B, and C, okay? And so here I'm just subsetting matrix A, asking me to return the rows corresponding to 1 and 2. I leave, there's a comma and a blank saying, give me all the columns, because, right, when you put in a blank into a subset, it returns everything. So here I've specified 1 and 2, so it gives me the first 2 rows. I've left a blank for the columns, so it's going to give me all the columns. Okay, using just like the other vectors that we did before, true, false, true. This is a little sloppy notation, just using capital T and F rather than the full word out. So this gives me the first and third rows, okay? So we can see that right here, the first and third row, and we're getting back to columns B and A. Okay. What is this? This says give me back none of the rows, okay? But give me all the columns except the second one. So you get this thing where you have basically just the names of the matrix and none of the rows, so basically nothing in there, but you get the names. Okay, the single bracket will simplify the results to the lowest possible dimension, okay? So if we look at A is a matrix, right? And if we say, is A a vector? Of course, it's going to say false. If we look at A1 comma, okay, and we're just getting back the first row, this is a vector. This is not a matrix of 1 row and 3 columns. It's a atomic vector with 3 elements in it, okay, because it's reduced the matrix. So this would be a matrix, right? But if we just ask for the first row back, it reduces it to a vector. That's its default value, default setting. You can prevent that by with an option called drop equals false. Well, I'll talk about this later. All right, so because matrices and arrays are implemented as vectors, right? So if you think of the internal storage of R, a matrix is a vector with dimensions applied to it, okay? And so you can subset a matrix as if it were a vector, okay? But you have to think, how does R store these values in vector form? Well, it stores them column-wise. So the vector would take this column down, down, down. This would be the 5th element in the vector. This then would be the 6th element all the way down, and this would be the 11th element, and so forth, okay? So it fills, because R fills these column-wise, or column major order, you have to keep that in mind if you're going to try to subset using a vector, okay? And so here's a neat little function called outer, okay? And so outer does outer multiplication, and if I just did 1, 5, 1, 5 without this function here, what it would do is it would return back 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, and this would be 5 times 5. So the default mode of outer, have you guys seen outer before? Here, it's worth taking a brief detour here, okay? So let's say I've got the vector 1 through 5. I can do 1 through 5, and then %O% is also a shorthand for outer multiplication. Okay, and what this does is it takes your elements 1 through 5, or your two vectors, and it puts them kind of on the margins. You just imagine one for the row and one for the columns, puts them in the margins, and then the default function that it applies is multiplication. Okay, so if it's like if you're trying to create every single possible combination of different things, right? So, you know, we could do like 2 through 4, outer multiply 1 through 5, okay? And so it'll take 2, 3, 4, and then 1, 2, 3, 4, 5, it goes across and multiplies these things. Okay, so it's a really neat function, and the longhand is outer. Okay, so 1:5, 1:5, and the default function is multiplication, but you can say the function I want you to use the paste function. Okay, and what paste does is it coerces things into characters and it glues them together. Okay, which is what it's doing here. It's taking you know, the thing from the row, and it's taking the thing from the column, and it's gluing them together. And what we're doing here is we're saying, okay, use function paste, but the default feature of paste is to glue things together with a space. Okay, but we can say glue them together with the separator character comma. And there you have it. Okay, so it's basically just saying, I've got all of these things, and I'm going to just make sure, it's like, I'm going to make sure everybody shakes each other's hands, and what do I get as a result? Okay, so outer's actually very useful if you're trying to, I don't know, for whatever reason you're trying to create every single possible combination between two vectors. Okay, you could even, I think, you can take a matrix and now I just want to make sure I'm doing this correct. Let's do that, and I think I can outer multiply this with another vector, and it will create a 2 by 2 by 2 array now. Okay, so this is the result of 1 times 3 times 5. This is the result of 1 times 4 times 5, and this will be the result of 2 times 3 times 5, and this is 2 times 4 times 5, and then this is everything instead of 5 but a 6. Okay, so outer just keeps building up your arrays this way. So anyway, it's pretty cool. So anyway, if we go, we're going to subset this matrix. This matrix vals looks like this, and I'm subsetting it using just a single vector. There's no comma here. Okay, so here it says, give me back the 4th element in the vector. Okay, if you store this matrix as a vector, give me back the 4th element. It says, here you go, that's 4, 1. Give me back the 15th element. Okay, so it's storing them as vector. So the 15th element is this one right here, 5, 3. Can we see that? Good. All right, and you can subset a higher dimensional structure with an integer matrix, okay, or a character matrix if it's named. And each row in this, so this is like the selection matrix, each row corresponds to a value, and then if you got a 2-dimensional matrix, then you're going to select it using basically a coordinate of 2. Okay, so it says, so each row is basically each value that you want to select, and then the 2 columns in the matrix that you're going to use to select will correspond to the coordinates of the points that you want to select. So this says, select 3 points. The first point I want is at coordinates 1, 1. The second point I want is at coordinates 3, 1. And the third point I want is at coordinates 2, 4. And if we use a matrix, so select is a matrix, and we feed that into the subset, we get back the 3 values that we've kind of located the coordinates of. Okay, and if you have a 3-dimensional array, then your coordinates require 3 dimensions, right? All right, so let's talk about data frames. Yes.
Can I go back?
Yes, of course.
So R is not space sensitive, right?
What do you, it is not space sensitive, that's correct.
So in this case, it would sort of just match the coordinates because it's a 2 by 2.
Oh, okay, so when I specified matrix, I said do this number of columns. I want 2 columns, and I'm writing it by row. True. Okay, so you know, if I copy this into R and I look at select, it looks like this. Okay, but you know, if you wanted to create the select matrix another way, you know, and you didn't want to specify, you'd have to, you know, create the vector 1, 3, 2, then 1, 1, 4, and then you'd have to do like number of columns equals 2. Okay, and that would also give me the same thing, but it's not so intuitive this way because, you know, if you wanted to write it out coordinate point by point, it makes sense to say fill it by row. Okay, so yeah, I kind of glossed over that a tiny bit, but it's just in writing our selection matrix. Yeah, this is just so our eyes can make easier sense of it, but and it works that way because we're doing by row equals true. It's not R is not smart enough to say, hey, you wrote it in this nice fancy way, therefore I'm going to turn it into a matrix that looks like this. Okay.
Okay. Thank you.
Yeah, but that's a good point that, you know, sometimes as I'm going through these things, I don't think about these things, but thank you for bringing up that question. Okay. Okay, so let's talk about data frames. So data frames, again, are a list, but everything in the list has the same length, and so you can create kind of this matrix-like structure. Okay, so here I'm just creating a very simple data frame with lists x, y, and z, and x has this, and y has this, and z is characters a, b, and c. Okay, and so we can subset using 2 vectors, just like we did with matrices. Okay, so I can subset using $x. So this says, give me the rows where $x is equal to 2, and then give me all the columns because I'm leaving this part blank. You guys see that? So this is a logical statement that says, I want the rows where the list x is equal to 2. And that would just be the second row. I can never tell if you guys are like, this is boring me to death, or like, I got this, right? You know, I'm just kidding. I'm sorry, this is subsetting. It's important, and I'm thinking some of this is probably new to you, right? Some of it. Okay. And then this just says, well, give me back the first and third rows, okay? And, or you can also select columns like you would a list. So notice there's no comma here, okay? So effectively, I'm subsetting a list, and this will return back a list, but it's okay because it's a data frame, and so we get it like this. Yes? Yeah. Okay, so when you put the comma after the C, this tells you I want the rows, right? So this, effectively, when you select it this way, you're selecting it using 2 vectors, except the second vector is blank, so it's going to select everything. So the first vector corresponds to which rows you want to select, and then the second vector corresponds to which column you want to select. Okay? You have to also think that a data frame is internally stored as a list, okay? And so we can select a list using like single bracket 1 single bracket 2, or if these lists are names, we can do single bracket A. Okay, and so when we do that, if this were, if I had a list here, what it would return would be a list with basically the containers or the lists that contain X and Z. And that's what's going on here. And I don't have a column because there's no rows. I don't put a comma over here because there's no rows that are named X and Z. I could put a comma in front of the C, and it would return the same thing, because if now I'm saying pick all the rows, but give me, if I put a comma right here, it would say give me all the rows but the columns that correspond to X and Z.
So is there any time when you have to put the comma like before the C, like, and where you won't just like?
Yeah, if you wanted to, if you didn't use the names, if they were not named, well, in a data frame they're always going to be named, I think. I'm trying to think. Oh, maybe. No, I'm not so sure. But if you wanted to just use like integers and just say give me the third column or the fourth column, then you would have to use a comma and put in the 3, because it wouldn't know what a 3 is here. Okay. Okay. So yeah, just so that's exactly what I said. So if I put the column there, then it's selecting columns like a matrix. Okay. Oh yeah, and this thing, I forgot about this. Okay, so there is an important difference that if you select, well, in this case they're going to be the same, but if you select a single column, okay, and if I use $X, not $, quote X, okay, remember selecting a list using single brackets always returns a list, right? And so if I look at the structure, it gives me back a data frame, because a data frame is effectively a list with just dimensions applied to it. Okay. Whereas if I use the matrix notation saying give me all the rows but the column that's named X, this simplifies it down to its just vector form. Okay, so there, yeah, I'm sorry, I forgot about this distinction. But this also happens. And again, depending on what you're trying to do with the subsetted functions, one thing might give you unexpected behavior. All right, so let's, here's a little quiz. Okay, so MT-cars, let me just show you what MT-cars is. It's a built-in data set. And MT-cars, MT being motor trend, okay? So motor trend reviewed like 32 cars or something, and this is the data it has. It's got like, here's the Mazda RX-4, gets 21 miles per gallon, it's got 6 cylinders, an engine size of 160 and 110 horsepower, and I don't know what this is. Something, okay, whatever. It's got all of these things, okay? So this is a data frame. Okay, and I'll do dim MT cars. Okay, see, oops, not dimmy. There are 32 rows and 11 columns in MT cars. Okay, so tell me what is wrong here. What I'm trying to get is the rows where the number of cylinders is 4. Okay, what's the operator? Double equals, yeah, exactly. So I need double equal, because this is like assignment, okay? So we want double equal, and this gives me what I want, for the ones with 4 cylinders. Okay. All right, and this one, -1:4. Yeah, what's it gonna do? Yeah, you can't combine negatives and positive integers for selection. Okay, this is kind of like saying, don't give me the first row, but give me rows So you can do rows 1 through 4, and this will just give you the first 4 rows. Okay, so this is the matrix notation where we're specifying rows and columns with 2 vectors. Yes?
If you just put parentheses between the 1 and 4, will that just take away the first 4 rows?
If I put
1:4.
1 colon, oh yeah, if I put a parentheses around, if I have negative parentheses 1:4, yes, that would remove the first 4 rows, yes. Okay, what about this one? So my operator is now correct. This is less than or equal to 5, the number of cylinders.
You need to like put a comma?
I need to put a comma there, okay? Because if I tried to do this, this would give me, how long is this thing going to be, this vector? There's 32 vehicles, so I'm going to get a vector of 32 trues and falses, right? Okay? And I could subset empty cars using trues and falses. However, those trues and falses now correspond to the columns, okay? So I have 11 columns, so I could feed a vector of trues and falses into a vector of 11 trues and falses, and that will select which columns I want. But here it's going to, if I tried to run this, it'll complain because it'll say, hey, you're giving me 32 trues and falses. I only have 11 columns. I don't know what to do. And when you write something like this, you're probably trying to select the rows. So you would need to put the comma in there, and then you'd get what you want. Okay. Okay, and what about this one?
Or again.
Yeah, so here you can't just do an or right like this. You can't be a little bit lazy with the or. You have to write empty cylinders equal 4 or empty cylinders equal 6. Okay, so you got to do it that way. Okay, I got another one of these. Oh yeah. Oh, I think I already answered this question, but what's wrong here? Yeah, I've got, I don't have 20 columns, I only have 11, okay? So I've got, this is going to try to select 20 columns in it, which I don't have. So probably just the first 20 rows. Okay, so we've got double bracket and $sign, all right? And when you're dealing with lists, you're going to need double bracket, okay? When you apply a single bracket to a list, it gives you back a list. And so here's a quote that's helpful, is that if you think of a list, if list X is a train carrying several objects, okay, or a train of objects, then X double bracket 5 is the object in car 5. Whereas X single bracket 4 through 6 is the train of cars 4 through 6. Okay, so what you're getting back is a list with basically the cars of 4 through 6, whereas if you use double bracket, it will give you the object that's inside the car. Okay. The thing about the double bracket is that it can only return a single object. Okay, so you cannot specify, you cannot put like 4:6 in here. You can't ask for more than one object using double bracket. You can only put in one thing. So here I've got a list. It's just 2 things in the list, okay? But double bracket 1 will give me the object inside the list, and that's just going to be 1. So this is going to be an atomic vector with one thing. Whereas if I use the single bracket, what would I get back? I would get list A equal 1, right? And then you can also use double bracket with character strings to subset. Oh, we're going to run out of time. Okay, so simplifying versus preserving. Again, when you use subsets to subset a matrix or something, it'll try to simplify it to a vector and things like that. Okay, if you don't want that to happen, then you can do drop equals false as another option inside the subset. Okay, so this is a table showing you if you want to preserve the list structure, you use the single thing. If you want to simplify it and just get the object inside, you use the double. Okay, and so let's talk about this. Okay, so with atomic vectors, using the double will remove the names. Okay, so effectively it's like the same thing, except keeping using the single keeps the names, using the double removes the names. Okay, and then and with a list, again, single bracket will give you a list back, double bracket will give you just the object inside the list. With factors, okay, if you put in drop equals true, it gets rid of any unused levels. Otherwise, it will retain all the levels in the original factor, even if they don't show up in the new factor. And then with a matrix, okay, so you specify which row you want, which columns you want, and then you put in a third argument inside the subset operation, and you say drop equal false, and that preserves the matrix structure. Okay, of course, it's only going to have one column now. I mean, one row now, but it preserves the fact that it's still a matrix. Whereas if you don't specify drop equals false, it reduces it to a vector. With a data frame, same type of thing as the list. Okay. Single bracket returns a data frame. Double bracket returns just whatever simplified version you get. Same thing if you wanted to use characters for a column. Okay. For selection, same idea. The $sign is shorthand to using double bracket with a character vector. Okay, so if you have named columns in your named columns inside your data frame, the $sign is effectively doing double bracket. So $sign simplifies it to whatever it is. Okay. Here's a common mistake. If you have the name of the column you want stored inside a variable, okay? mtcars $sign variable doesn't work, but do mtcars double bracket the variable, okay? Because then it puts the character inside here, and you get what you want. One important difference is that the $sign will do partial matching. So if you do $sign A, it'll try to match, whereas character thing will not. So if you're lazy, you can use $sign in just the start of the column name. Okay, but that could get you in trouble. So it's always good to use the full column name when you're trying to do things. But if you're just in a hurry, you can use the $sign. This is getting real technical in like what happens if you specify something that's out of bounds. Okay, and this is a common error. If you're like when you're doing loops when you write functions and loops, a lot of times you didn't define the ends of your loops correctly or well enough, and you'll get out of bounds errors. Okay, and so this is like your vector only has 4 elements in it, and you're asking for the 5th thing. You know, what's it going to give back? This is all this. Okay, and so it's all in the table. This is basically just what happens if you specify something that's out of bounds, and you've got an atomic vector or a list. You know, will it give you an error, or will it give you just an empty empty thing, okay? Good to know, but probably really boring to go over each individual one. Okay, so subsetting an assignment, oh dear. We're gonna run out of time here, but you can, so if I start off with the numbers 1 through 5, I can say, okay, the first 2 elements in X, I want to reassign to, or assign the values 2 and 3, and we see that happening, okay? If you're going to do some other thing, you've got to make sure that if you're going to do assignment, they need to match. There's not going to be a recycling that works with assignment here, okay? There's nothing that checks for duplicate indices. So if you say 1 and 1, it's going to take 2 and assign it to the first one, and then it's going to take 3 and assign it to the first one. Okay, and so what you end up getting is just the 3 back. Okay, and then again, you can't combine these things with NAs, and but you can combine logical indices with NA, and you get some slightly quirky behaviors here, but it's not too bad. Okay. But so you can, this is very useful when you're dealing with a data frame. You can then say, here, I want to take the data frame, and if it's less than 5, if A is less than 5, I want to reassign it to 0, or whatever. You take a true false statement. Okay, so notice I'm using $sign here to say I want to look at this vector inside A. And then I'm using the single bracket to then specify exactly which ones using the true-false notation, and then I'm specifying, reassign that to a 0. So here I got 110 in NA, and it says which ones are less than 5? The 1 is, and now we're going to reassign it to 0. Okay, so this. Because of this thing, it will when you're applying when you apply as.integer to empty apply, list apply, it's going to just turn everything. It's basically just dropping the decimals. It's turning everything into integers. This one preserves the list structure. This one simplifies it. Okay. You can remove things by assigning null to certain elements, okay? If you want to use a single bracket, remember this is so you can remove an entire column inside a data frame or entire object inside a list by assigning null to that to the simplified version, okay? But if you use list null, it preserves this list existing, but it puts the null inside there, okay? So these are kind of like finer points of all of this stuff that maybe if you're running into problems in your programming, it'll be good to look back. The important applications, we're going to run out of time here, but I encourage you to go through this. I'll post these notes up here. But you can create lookup tables where you can then, if you want to replace letters M and F in a vector, you can replace them with male and female using a lookup table. This is incredibly useful. And you can match all of these things. So I encourage you to at least work through these applications, because these are they're very handy to have in your toolkit as you try to do some programming in R. Okay, so I apologize that we've run out of time for this, but we'll see you guys next week. Good luck on the homework. It's due Monday evening, so we'll see you then.
Wednesday, the